Homeostasis of lymphocyte populations is maintained by signals that lymphocytes are continually receiving through their antigen receptors. Most of what we know about signaling through the B-cell receptor and the T-cell receptor derives from observations in cultured B-cell and T-cell lines. In these cells, the tyrosine kinases SYK and ZAP70 are recruited as a consequence of receptor clustering and the subsequent phosphorylation of ITAMs in the receptor subunit tails. However, in T cells isolated directly from lymph nodes or the thymus, ZAP70 is already bound to partly phosphorylated zeta chains but is not yet activated. The same state can be produced in both normal naive T cells and cultured T cells by exposure to altered peptide ligands. It therefore seems likely that the phosphorylated ITAMs and bound ZAP70 seen in mature naive T cells in vivo reflect the receipt of signals from self-MHC molecules bound to self-peptides that behave like altered peptide ligands. The ability to interact with self-peptide, self-MHC ligands is a criterion for survival during T cell development in the thymus. Developing T cells are subject to stringent testing once the alpha-beta T cell receptor is expressed. The selection process retains those cells whose receptors interact effectively with various self-peptide, self-MHC ligands, positive selection, and removes those T cells that either cannot participate in such interaction, death by neglect, or recognize a self-peptide, self-MHC complex so well that they could damage host cells if allowed to mature. Such cells are removed by clonal deletion, negative selection. Those T cells that mature and emerge into the periphery have therefore been selected for their ability to recognize self-MHC, self-peptide complexes without being fully activated by them. A number of studies have now shown that naive T cells in the peripheral lymphoid tissues continue to receive signals through interactions with self-MHC, self-peptide complexes. These signals enable the cells to survive and are delivered most effectively by the cells that are most capable of T cell activation, namely the dendritic cells. Thus, the T cells in mice transgenic for a T cell receptor that is positively selected on a particular self-MHC, self-peptide complex can survive only if they receive similar signals from self-MHC, self-peptide complexes in the periphery. It seems as though the peripheral T cell repertoire is maintained by a continuous dialogue between dendritic cells presenting self-peptides on self-MHC molecules and recirculating naive T cells that were positively selected by signals from the same self-peptide, self-MHC molecules during development. This dialogue is likely to account for the state of partial phosphorylation of the zeta chains. A requirement for repeated interaction with dendritic cells resident in peripheral lymphoid tissue could also account for the tight regulation of the numbers of naive CD4 and CD8 cells. For memory T cells, the factors that govern survival are less well defined. It is clear that self-MHC, self-peptide recognition is not required for the survival of memory T cells. In fact, the presence of MHC molecules does not seem to be required at all. Rather, it is likely that the levels of particular cytokines serve to maintain the memory T cell pool. And that's homeostasis of lymphocyte populations is maintained by signals that lymphocytes are continually receiving through their antigen receptors.